Welcome to Math Essential Vector Calculus. Today we are going to discuss about cross product. The purpose of this video is to define the cross product and understand how it is calculated, also to introduce some of its applications. Let's start with the definition. The cross product produces a vector that represents the area and orientation of the parallelogram formed by two vectors. Let's learn how to calculate the cross product analytically. We are given in 3 dimensions two vectors A and B. The cross product of A and B, A cross B, we use this sign. So before, when we have the dot product, we use the dot. This in case dot product. So the easiest way to memorize, you just put the unit vectors A1, A2, A3 in the first line of a determinant. Then we put the first vector A1, A2, A3. Then we put the second vector components in each direction B1, B2, B3. Simply, if you solve this determinant, you will reach to this formula. So let's memorize together. The first thing is that here we have positive, negative, positive sign. Assume we want to calculate the component in the direction of A1, so we cancel this column and row. We multiply like this A2 B3, then again we multiply but with minus sign A3 B2. Likewise we can do in the A2 and A3, but just remember that you need to take care of the sign, especially in A2. So A2 actually you will find these two terms reversed due to this negative sign. Finally, one tip, the result of cross product is always a vector which is perpendicular to both of the two vectors which we operate the dot product on. Now we move to the geometrical calculation of the cross product. Geometrically, we can calculate this cross product as magnitude of A multiplied by magnitude of B multiplied by sine alpha, where alpha is the angle between A and B. But note that this is not the complete cross product. This is just the magnitude of the cross product. The direction of the cross product is perpendicular to both A and B. So if we look to the graph which we have, since A is rotating anti-clockwise, then the direction of the normal will be going inside the page. Now we move to the applications. Starting from the area of parallelogram, calculate surface area spanned by two vectors A and B as shown in the equation. Now we are with the second application of cross product, which is a torque. Torque is the rotational correspondent of linear force and can be calculated as tau equal to R cross F, and R is the arm of the torque. As we can see, when we rotate based on the direction of rotation, either we'll have generated torque in the downward direction or in the upward direction. Magnitude of the torque is equal to magnitude of R multiplied by magnitude of F sine alpha, and this alpha assumes that your force, if we plot, for example, this is our R, and if our force is like this, for example, means it is not perpendicular to the R, then you will lose some of this force in terms of sine alpha. Finally, torque direction will be calculated by the right hand rule. If we are rotating anti-clockwise, then you will have the torque in the up direction. If you're rotating clockwise, then you will get in the downward direction. The third application of cross product in this video is the Poynting vector. In electromagnetism, the Poynting vector represents the directional energy flux or the power flow of an electromagnetic field. It can be calculated as S the power equal to E the electric field multiplied cross product with the magnetic field H. As we can see in the figure, if we have E directed in the K direction, H directed in the I direction, then we will get the field propagating or the Poynting vector in the J direction, because K cross I is equal to J. So Poynting vector direction will represent the propagation of the electromagnetic wave, and the magnitude simply can be calculated again as S magnitude is equal to E magnitude dot H magnitude multiplied by sine alpha, where alpha is the angle between E and H. In conclusion, the cross product is a detector of area and orientation. It has many applications, which we got some examples here. We can calculate the area in geometry, we can calculate the torque in mechanics, and also in electromagnetism we can calculate what's called the Poynting vector. Thank you.